let's come to the third type of reaction. That is, we learned about combination reaction, then we learned about decomposition reaction. Now we are going to study about displacement reaction. What? The third one is displacement reaction. Okay. So, what will be known as displacement reaction? Can you try to guess from the name? Displacement reaction. Yeah, as the name suggests, a displacement, a change of position is happening. Understood? So here I'll show you. Suppose A is combining with BC on the reactant side. The product got is B plus AC. See, in this reaction, A took the place of B and B came to the place of A. That means A combined with C and AC was formed. Which means here A is displacing B. Understood? A is displacing B. So, displacement reactions are those reactions in which a more reactive element replaces or displaces a less reactive element from the compound. Okay, so here which is more reactive? A is more reactive. That is why A is more reactive than B. That is why A is displacing B and combining with C. So what is a displacement reaction? A displacement reaction, you can write down the notes. A displacement reaction is a reaction in which a more reactive element displaces a less reactive element from its compound. Okay. For example, zinc is combining with copper sulfate. Okay. Here, zinc is more reactive than copper. See, there is a reactivity series. You will learn that in your third chapter. Okay, I'll teach you that in your third chapter. In that, the elements are arranged according to their reactivity. So, from that table, you will know that zinc is more reactive than copper. So, when zinc is combining with copper sulfate, what happens? Zinc will displace copper and what will be formed? Zinc will be coming in the place of copper. So, zinc sulfate and copper will be formed. Okay, this is the example for displacement reaction. Understood? Now we are coming to fourth type of reaction, that is double displacement reaction. Okay, fourth is double displacement reaction. Okay, now what will be double displacement reaction? From the name of this reaction, what can you understand? What can you guess? Yes, displacement is happening. How many times? 2 times. There is double displacement is happening. Let's see what happens. Suppose AB is combining with CD. This is the reactant side. Here what happens? A will take the place of C and C AB plus CD means mutual exchange happened. A gave his position to C and C gave his position to A, means mutual exchange of ions happens in double displacement reaction. Okay, example, NaOH, sodium hydroxide is combining with hydrochloric acid, HCl. Here what happens? Sodium will come in the position of hydrogen and hydrogen will combine with OH ion. So, Na is combining with Cl, NaCl. Now hydrogen is combining with OH. Then what is formed? H2O. So here what happened? Double displacement happened. So this is known as double displacement reaction. Okay. So now we learned about 4 different types of reaction. Now before going to the 5th reaction, redox reaction, let's see a subtopic, types of reaction. Okay, based on energy flow. Okay, types of reaction based on energy flow. Okay. See, when this chemical reaction takes place, in some cases heat will be absorbed by the reactants to change into products. Okay, so in some chemical reaction heat is taken inside, and in some chemical reaction heat is liberated, means heat is given out. So in that manner, means energy flow, if the energy is taken in or is the energy given out, in that manner the reaction can be classified into endothermic reaction, and exothermic reaction. Okay, now what will be endothermic? Endo, inside. So endothermic reactions are those reactions in which energy is absorbed. Okay, absorbed or energy is supplied. Okay, so energy, what happens? Energy is supplied, means we have to supply energy, we have to give heat. Energy is supplied or energy is absorbed. Here what will be exothermic reaction? Exo, out, in which the energy is released or energy is evolved. Exothermic reactions are reactions in which energy is released or energy is evolved. Okay, understood? For example, the same reaction which I have already taught, calcium carbonate, heated, I am supplying energy, I am heating. When calcium carbonate is heated, what happens? It decomposes to calcium oxide and carbon dioxide. Here energy is taken in by the calcium carbonate, so it is endothermic reaction. Now exothermic, methane reacts with oxygen, means this is burning of natural gas. Okay, methane, when natural gas is burnt, what are the products formed? Carbon dioxide plus water plus heat. When you are burning natural gas, what we get heat, no? We get heat, no? Right? So we are getting, means heat is getting released, that is why we are getting that. So burning of natural gas combines with oxygen to form carbon dioxide plus water plus heat. This is exothermic reaction. Understood? So these are the two types of reaction based on energy flow. Now we are coming to the last type of reaction, that is a redox reaction. Okay, redox reaction. So from the name redox reaction, what can you understand? What is meaning of redox reaction? Redox reaction is a reaction in which reduction and oxidation both takes place. You have learned in your previous classes, 8th standard and 9th standard, you learned what is known as reduction and oxidation. Okay, but still I'll teach you here. So when oxidation and reduction takes place simultaneously in a chemical reaction, then that is known as redox reaction. Now let's see what is known as reduction and what is known as oxidation. Listen here carefully. Okay. So, reduction means the process of removal of oxygen is known as reduction. What? Process of removal of oxygen. Removal of oxygen is known as redox reaction. So what will be oxidation? Oxy means process of adding of oxygen. Process of adding of oxygen. Okay. So oxidation is adding of oxygen and reduction is removal of oxygen. Now, in another way, how can we define? Reduction is adding of hydrogen. Adding of hydrogen. And oxidation is removal of hydrogen. Removal of hydrogen. Okay. Now, third way. Reduction is addition of electron. Addition of electron. And oxidation is removal of electron. Removal of electron. So, if suppose you are getting a question to find out whether reduction is happening or oxidation is happening, you have to check for these. If removal of oxygen is happening there, then that is reduction. If addition of hydrogen is happening there, then that is also reduction. If addition of electron is happening, then that is also reduction. Then what will be oxygen? If addition of oxygen is happening, then that is oxidation. Removal of hydrogen is happening, then that is oxidation. Removal of electron is happening, then that is oxidation. Okay, for example, see, copper, having a copper ion. Copper ion means Cu2 plus. This is not a copper atom. Okay. Copper atom is stable. This is copper ion. 2 plus represent that it has lost 2 electrons. If I am giving 2 electrons to this copper ion, then I will get what? Copper atom. See, here addition of electron is happening. Addition of electron. Then this is what? Reduction reaction. Now, example for oxidation reaction. I am having a zinc atom. The zinc atom, see, in this reaction, zinc ion, it is splitting into zinc ion and 2 electrons. Here see, from the zinc atom, 2 electrons are removed. Means atom is turning into zinc ion. It is becoming zinc ion means what? It is losing 2 electrons, right? So removal of electrons is happening, which means it is oxidation. Understood? So this is the example for reduction and this is the example for oxidation. Now let's see an example for redox reaction, which means in a single reaction both oxidation and reduction will be taking place. See, I'll write here. See this. Zinc is combining with copper sulfate to form zinc sulfate plus copper. Okay, all right. This zinc is solid, copper sulfate is aqueous, zinc sulfate is aqueous and copper is solid. See here, can you tell me whether oxidation and reduction happened here? Yes, both oxidation and reduction happened in this single reaction. See, here what happened? In the first, on the reactant side, the copper was existing as copper ion. See, it is in a combined form with sulfate, no? So here the copper is copper ion, right? but when on the product side copper is becoming copper atom, which means copper has gained electrons. Copper has gained electrons. So addition of electron. So here what happened? Reduction happened. Right? Reduction happened. The copper ion gained electron and became copper. So that is reduction. Now what happened with the zinc? The zinc was an atom. It lost electron and became zinc ion here. So here removal of electron happened, which means oxidation happened here. Followed. So both oxidation and reduction is happening in a single chemical reaction. So this is known as a redox reaction. Okay. Also, can you tell me, this is an example for one more? Yes, displacement reaction. See, the zinc is displacing copper. So this is an example for displacement reaction as well as a redox reaction. Followed? Yeah. Now, one more thing. One more thing. Just listen. Here, what is the role of zinc and what is the role of copper? Okay, see, oxidation happened to zinc. Zinc has undergone oxidation. So zinc will be known as the reducing agent. Exact opposite, reducing agent. What is with copper? Reduction happened. So copper will be oxidizing agent. Oxidizing agent. Never get confused. Reduction is happening. Reduction happened to copper. So copper will be oxidizing agent. Reduction happened. That will be oxidizing agent. Zinc, oxidation happened to zinc. So zinc will be reducing agent. The opposite. Understood? So don't get confused with this portion. So that's it about the 5 different types of reaction.